All right, so get this. We're going deep today. Integer sequences.
Oh, yeah, I love these.
Like those lists of numbers mathematicians go crazy for.
Yeah.
Our guide is the online encyclopedia of integer sequences. Think of it like a huge digital library just for these sequences. And we're focusing on one specifically, A00000000.
This one, it's deceptively simple.
Oh.
You'll see. It's just the initial digit of each number.
Okay, starting digits. Where's the mystery?
Oh, trust me, there's a rabbit hole here. Leads to some pretty mind-blowing math concepts.
Right, I'm hooked. What does this sequence actually look like?
Well, it starts off, normal, 0, 1, 2, 3, and so on.
Right.
But then, hold on, you get 10 ones, then 22s, 33s, and it keeps going.
Each digit repeats, but more and more each time.
Exactly. It's a pattern.
And there's a formula for this.
Of course.
stuff.
It uses, well, it might look complicated at first, but it's basically figuring out how big the number is.
Ah, I see.
Which tells us which digit repeats and how many times. It's like a code. Unlocks the sequence's pattern.
Clever. Looking at this sequence, A00000030, I can't help but notice the name itself. Like, it has a pattern, too. 5 zeros and then 30. Almost like the sequence is right there in the name.
Whoa, hold on. You might be onto something there. Remember how it starts? Each digit 10 times, then 100, 1,000, those 5 zeros.
Powers of 10.
Yeah.
And the 30. The digits 3 and 0. They're everywhere in this sequence.
It's like the name is giving us clues about the structure, how it behaves.
Love these deep dives. Always something hidden to uncover. But let's not get ahead of ourselves. Where would we even see this sequence in the real world? Seems pretty abstract.
Oh, you'd be surprised. Think about graphs, logarithmic scales, or analyzing a ton of data, financial records, for example. The patterns of A000030, they might be hiding right there.
So we could be seeing it without even realizing.
Right.
Hey, the OEIS entry also has this comment section.
Yeah.
Seems pretty in-depth. What's hidden in there?
Well, one comment connects A00000030 to another sequence. A217657.
Okay.
Get this. Sometimes you can combine a number from our initial digit sequence with its corresponding number in A217657, and you get back the original number.
Wait, what? You're kidding. How?
Let's take 23. Initial digits 2, right?
Right.
The 23rd number in A217657, it's 3. Combine those digits, and bam, 23.
That's wild. Like they're working together, encoding numbers.
Exactly. A secret language.
Okay, so even first digits. There's so much depth.
Oh, yeah. There's more. The OEIS entry, it has references, cross-refs, all sorts of connections.
Yeah, I see that. Even it mentions the Encyclopedia of Integer Sequences book. Sounds like a dream for math lovers. What about the cross-refs? Anything interesting there?
One links A000000 to A010879, the sequence of final digits.
The beginning and the end. Interesting.
And speaking of digit patterns, there's this thing called Benford's law ties into all of this.
Oh, yeah, Benford's law. I've heard of it. Something about how often digits appear in data.
Yes. In many data sets, stock prices, population figures, the first digit is more likely to be a 1 than a 9, a 2 more likely than a 3, and so on.
Seems counterintuitive.
Yeah.
But it's everywhere.
It's a real thing. And it has applications. We're talking fraud detection, analyzing elections, even validating scientific data.
Hold on. You're saying by looking at the first digits, we can catch criminals, make sure studies are legit.
Exactly. Fraudulent data, it often doesn't follow this natural distribution of digits, so auditors, they can compare what they see to what Benford's law predicts. If it's off, red flag.
This is incredible. We started with initial digits, and now we're talking fighting crime, ensuring scientific accuracy.
It's all connected. And those references, cross-references in the OEIS entry, those are like doors to a whole universe of math concepts.
We can spend hours on those. But for our listeners, let's stick to the key takeaways from A000000.
Sounds good. One big thing, I think, is observation, curiosity. Who knew that just noticing the pattern of initial digits could lead to such big discoveries?
It's like math isn't just formulas. It's about patterns, connections, asking why.
Absolutely. What stayed out to you most so far?
Honestly, the unexpected connections. First digits in fraud detection, mind-blowing. It shows how math is this interconnected web. Even the simplest things have huge implications.
Couldn't agree more. And that interconnectedness, it's what makes math so fascinating. Speaking of which, there's this one cross-reference I think we should talk about. It links A000000 to sequence A037904.
Oh, And what's special about this one?
It looks at the number of times a certain digit appears as the leading digit in the first n positive integers.
So like taking the idea of initial digits from A000000 through 0 and getting statistical, how does this tie back to Benford's law?
Well, remember how Benford's law predicts those probabilities? A037904, it lets us actually count those occurrences within a specific range of numbers.
I get it. Compare the counts from A037904 to what Benford's law says, and that tells us how well a data set matches those predictions. Super useful for fraud detection.
Precisely. It's another tool. And it all goes back to those initial digits. A000000.
This whole deep dive has been amazing. Abstract patterns, real-world data, statistical analysis, applications in finance and science. It's incredible how one sequence can branch out into so many different areas.
It really shows the beauty and how everything in math is connected, and it reminds us there's always more to learn, even in the things we think we already know.
Well, I'm already excited to tackle another OEIS sequence, but for now, I think we've reached the end of our journey with A00000000. What's one final thought you want to leave our listeners with?
I'd say this. Don't underestimate the power of simple observations. The sequence of initial digits, it might seem basic at first glance, but as we've seen, it has far-reaching implications, and it connects to so many different mathematical concepts. Who knows what other secrets are hidden within seemingly simple patterns?
Well said. So to all our listeners out there, keep exploring, keep questioning, and never lose that curiosity for numbers and patterns. You never know what amazing discoveries are waiting out there.
And with that, we'll wrap up this part of our deep dive into the fascinating world of A000000. So we've been talking about A000000, right? All about that first digit.
Right.
But you might be thinking, okay, what's the connection to Benford's law? Good question. It seems like on one hand you have this pure math sequence, and then on the other, real-world data.
Yeah.
But that's the cool thing about math. These things that seem totally different, often they're deeply connected.
Explain it to me like I'm 5 then. How do first digits relate to like how data is spread out in the real world?
Imagine a stock price going up.
Okay.
It's going to spend more time with a 1 in front than a 9, right? It has to go through all those 100s of thousands before it even gets to the 900.
Oh, yeah. Like those early digits are bottlenecks. Yeah. Numbers got to pass through them to grow.
Exactly. And this isn't just random. Benford's law, it describes this, and it has some crazy applications. Fraud detection, looking at election results, even making sure scientific data is good.
Wait, hold on. You're telling me by looking at the first digits, we can, like, catch crooks and make sure studies are on the level.
You got it.
Yeah.
See, fake data, it often doesn't follow this natural way digits are spread out. So auditors, they can compare what they actually see to what Benford's law predicts. If things don't match up, red flag.
We started with initial digits, and now we're talking about, like, stopping crime and bad science. Incredible.
And there's more. Remember all those references, cross-references in the OEIS? Like portals to a whole other world of math ideas.
Yeah, we could get lost for hours in those. But for our listeners, maybe let's focus on like the biggest takeaways from A000000.
Agreed. I think one of the most important things here is just paying attention, being curious. Who would have thought that looking at those first digits could lead to such big discoveries?
It's a good reminder that math, it's not all about memorizing formulas. It's about looking for patterns, making connections, asking why.
Exactly. What stood out to you the most in our A00000000 journey so far?
You know, it's the unexpected connections. First digits linked to fraud detection blows my mind. Shows that math, it's like this web, everything's connected. Even the simplest things can have huge consequences.
Couldn't have said it better myself. And that interconnectedness, that's the beauty of math.
Yeah.
You start exploring one thing and boom, you stumble onto all these fascinating links to other ideas. Speaking of which, there's one particular cross-reference I think we should highlight. It connects A000030 to sequence A037904.
Oh, okay. What's so interesting about that one?
It focuses on, well, the number of times a specific digit shows up as the leading digit in the first n positive integers.
So we're taking those initial digits from A000003 and kind of looking at them statistically. How does this connect back to Benford's law?
Remember how Benford's law predicts the chances of different digits appearing first? A037904 actually lets us count those instances in a set range of numbers.
I see. So we could compare the counts from A037904 to what Benford's law predicts, and that tells us if a data set is following those predictions or not. Must be super helpful for that fraud detection stuff.
Exactly. Another tool in the toolbox. And it all circles back to A000030, that sequence of initial digits.
This whole deep dive has been full of surprises. We started with abstract patterns, and now we're talking real-world data, statistical analysis, stuff in finance and science. Amazing how one sequence can have so many branches.
It really does highlight the beauty of math, how it all connects together. And it reminds us that there's always something new to learn, even in the stuff we think we know.
Well, I'm ready to jump into another OEIS sequence, but for now, I think we've reached the end of our exploration of A00000000. Any last words of wisdom for our listeners before we move on?
Don't ever underestimate simple observations. The sequence of initial digits, it might seem basic at first, but as we've seen, it has these huge implications. Connects to all these different math ideas. Who knows what other secrets are hidden in plain sight, just waiting to be discovered.
Well said. To all our listeners out there, keep exploring, keep asking questions, and never lose your curiosity about the world. There's a whole universe of patterns and connections waiting to be found. It's funny, right? We've spent all this time on the sequence itself, but we haven't really talked about the name. A00000. Simple, but kind of cool.
You know, the name itself, it almost mirrors the sequence, doesn't it? You have that A, then 5 zeros, and then 30.
You're right, that 30 at the end.
Yeah.
It's like it's pointing to those digits, 3 and 0. They're everywhere in the sequence.
Yeah.
And the 5 zeros, could those be about how the digits repeat? 10 times, 100, 1,000.
It's very possible. Remember how the sequence grows? Those 5 zeros could definitely be a nod to those powers of 10.
It's like a hidden message right there in the name. Makes you wonder if other sequences in the OVIS have those little secrets too.
That's a great thought. Adds a whole other layer to exploring the OEIS, doesn't it? It's like each sequence has its own special fingerprint, not just the numbers, but the name too.
This whole deep dive has been incredible. Started with something that seemed simple, just first digits. And look where we ended up. Logarithms, real-world data, fraud detection, even hidden stuff within the sequence's name.
It really is amazing, isn't it, how math can take something so basic and lead to these huge insights. And it reminds us there's always something new to find, even in the things we think we already get.
So, as we wrap up our A000000 journey, what's the big takeaway you want our listeners to remember?
I think it's this. Never underestimate simple observations. The sequence of initial digits, it might seem trivial, but as we've seen, it has these huge implications. It's connected to so many different math ideas. Who knows what other secrets are out there hidden in plain sight?
Absolutely. To all our listeners, keep exploring, keep asking questions. Don't ever lose that curiosity for numbers, for patterns. There's a whole world of amazing discoveries out there just waiting to be found. And that wraps up our deep dive into the fascinating world of A000000. Thanks for joining us.